Assalamualaikum viewers. Today we are going to discuss about conservation laws. In previous classes, we have studied law of conservation of momentum, energy, and electric charge. Let's take an example of law of conservation of electric charge. By observing outcomes of many processes, we are able to propose this law. The net amount of electric charge must not change in any process. That is, the net charge before a particular reaction or decay must equal to the net charge after the reaction or decay. So in simple words, we can say that law of conservation means something remain constant before and after the reaction. Let's take an example of nuclear fusion equation. Deuterium has an electric charge of +1, while tritium has also an electric charge of +1. And on the product side, we have helium. Helium has an electric charge of +2. And as far as neutron is concerned, it is neutral in electric charge. So here, +1 and +1 on reactant side, so it is adds up to +2. And also the electric charge on the product side is +2. So the law of conservation of electric charge is validated. The conservation laws help us to understand why certain phenomena occur and why certain processes are never observed. When conservation laws are violated, a process is impossible to occur in normal conditions. At particle physics, we will study about conservation of lepton numbers, baryon number, and strangeness. Starting with the conservation of lepton number. There are 6 particles in lepton number, while 6 are anti-lepton number, as almost every particle has an antiparticle. Lepton number +1 is assigned to 6 leptons, and -1 is assigned to 6 anti-lepton number, and -1 is assigned to 6 anti-leptons. Here's a table. It shows the basic 6 leptons: electron, electron neutrino, muon, muon neutrino, tau, and tau neutrino. This all has +1 lepton number, while their antiparticles, that is positron, anti-electron neutrino, anti-muon, anti-muon neutrino, anti-tau, and anti-tau neutrino, has a lepton number of -1. As far as the electric charge is concerned, 3 particles, that is electron, muon, and tau, has -1 electric charge, and rest of 3 particles, that is electron neutrino, muon neutrino, and tau neutrino, has a 0 electric charge. From this table, we have deduced 2 simple and important tables which will be helpful to solve problems regarding law of conservation of lepton numbers. This table is for particles, that is leptons, and this is for antiparticles, that is anti-leptons. As we have already discussed, particles has lepton number of +1. So these all 6 particles has a lepton number of +1, while these all antiparticles or anti-leptons has a lepton number of -1, opposite to this +1. While their electric charge, electron, muon, and tau has an electric charge of -1, and electron neutrino, muon neutrino, and tau neutrino has an electric charge of 0. Similarly, anti-electron, anti-muon, and anti-tau has an electric charge of +1. This is opposite to this -1. Particles and antiparticles are opposite in their electric charge and in their lepton numbers. Anti-electron neutrino, anti-muon neutrino, and anti-tau neutrino has an electric charge of 0. While the electron number of particles is +1, so the antiparticles has the lepton number will be -1. From these 2 tables, We will solve the following equation. Here we have to find out the identity of X particles using these law of conservation of lepton number. First, we will see either electric charge is conserved or not. For anti-muon, the electric charge is +1. We don't know the electric charge of X, so moving towards electron neutrino. The electric charge of electron neutrino is 0 and the electric charge of anti-muon neutrino is also 0. So, as far as electric charge is concerned, we have to put the same electric charge on both left and right side or on the reactant and product side. So here it is +1 and while there this is 0. So the identity of X is +1. Now this is same +1 on reactant side and +1 on product side. So the electric charge is conserved in this sense. Now moving towards the lepton number. Anti-muon has a lepton number of -1. We don't know about the X, so moving towards electron neutrino. The lepton number of electron neutrino is +1, while the lepton number of anti-muon neutrino is -1. Both these will be cancelled out. So we are having -1 on reactant side. There must be a -1 on product side to conserve the law of lepton number. So we have the X particle with the electric charge of +1 and lepton number -1. Let's identify the particle. Here it is, lepton number -1 and electric charge +1. But wait a second, there are three particles, anti-electron, anti-muon and anti-tau. Which one be possibly X? Oh, there is confusion. But don't worry, the following table will clear all the confusions and we will reveal the identity of X particle very clearly. Here's the concept of lepton family number. As there, so conservation of lepton number is the lepton number for electron type leptons, muon type leptons, and tau type leptons must remain constant. So for this, here is a table. Electron family lepton number will be +1 for electron and electron neutrino. And for rest of two, it would be 0. And for muon and muon neutrino, electron family number will be 0 because this is muon, not an electron. Muon couldn't be present in the electron family. Muon will reside in muon family only. So, in rest of two families, that is electron family and tau family, muon number will be 0. It will be only +1 in muon family number. And similarly for tau family, only tau and tau neutrino is +1. For others, tau neutrino will be 0. Tau is only present in tau family, not in muon family or not in electron family. Or tau family will only accommodate tau and tau neutrino. And electron neutrino, muon and muon neutrino are not allowed in tau family. These are lepton family are particles. For antiparticles, that mean anti-leptons, we have opposite family numbers. That is where +1 will be converted into -1. That is, for instance, positron has the electron number will be -1. For instance, positron would have the electron number or electron family number is equal to -1. So now we can easily identify the X particle. Here, for C, electron family. This is muon. So muon is not allowed in electron family. So here it would be 0. Now we have electron neutrino. Electron neutrino belong to electron lepton family. So it would be +1. This is the lepton, not anti-lepton. So +1. And this is anti-muon neutrino. For lepton number, it would be 0. Because we already discussed that electron lepton will only accommodate electron and electron neutrino. Not muon or muon neutrino, anti-muon neutrino are not allowed. So here from law of conservation of electron lepton number, both sides must be equal. On the reactant side we have 0, while on the product side we had +1. So here we need a number which will cancel out +1 so that we have 0 on product side as well. So this is certainly -1. Now -1 and +1 will be cancelled and we will have 0 on this side and also on this side 0. So it is clear that X particle belong to the electron lepton family. Now let's reveal the identity. That is, from these three, the X particle is anti-electron. So X is equal to anti-electron. Moving ahead, we have some different type of problems to dwell the concept more deeper. Analyze the decay of muon from the state point of conservation of lepton numbers. In this, we have just to understand that conservation of lepton number is applied here. For instance, for electron lepton family, muon would be 0. Muon is not allowed in electron lepton family. And electron will be +1, while anti-electron neutrino will be -1. And also muon neutrino will be 0. This is not a particle of electron family, so it is 0. Now, on the reactant side we have 0, while on the product side we have +1 and -1, which will cancel out each other, and we will have 0 on the product side as well. So lepton number is also conserved. For muon lepton number, muon belong to muon lepton family, so +1. Electron doesn't belong to muon lepton family, so 0. Also anti-electron neutrino doesn't belong to muon family, so it would be also 0. And muon neutrino belong to lepton family, so also +1. On reactant side we have +1, on product side we have +1, so lepton muon number is also conserved. Only you have to memorize these 3 tables and you can easily solve all type of problems regarding lepton conservation. So moving towards another problem, that is, analyze the decay of falling particles from the standpoint of conservation of lepton numbers. So we have to check either all the conservation laws are valid here or not, or any law here which violates the law of conservation. Starting from the electric charge, for neutron, electric charge is 0. For proton, the electric charge is +1. While for the electron, it is -1. And for electron neutrino, the electric charge is 0. +1, -1 will cancel each other. So resultantly on the product side and reactant side, we will have a 0. So electric charge is conserved. Now moving towards lepton number. Neutron is not a lepton. Other than lepton, all particles will be 0 in lepton number. Just like mesons, baryons, that is neutron, proton, pion, all will be 0. So lepton number will be 0. Proton is also not a lepton, so 0. While electron is a lepton, so here is a lepton number that is plus 1. Electron neutrino is also a lepton number, so plus 1. So law of lepton number is not conserved. While electric charge was conserved. This simply means that reaction is not possible because it violates the law of conservation. Moving towards another problem, it is collision of electron and positron. So first we will check either electric charge is conserved or not. For electron, electric charge is -1, and for positron, electric charge is +1. While these are 0 and 0. So the electric charge is conserved. Now moving towards lepton number. The electron will have a lepton number of +1 and the positron has a lepton number of -1. You don't have to confuse electric charge number with the lepton number. Look, for leptons are particles, lepton number is +1, and for antiparticles, lepton number is -1. And electron is an electron having a negative charge, so its electric charge is -1, and an anti-electron would have a charge opposite to that of particle, that is +1. Also, these are not leptons, so 0 and 0. So lepton number is also conserved. If we further move towards electron-lepton family, we will see it will also be conserved. For electron, it is +1. For positron, it is -1. And for these two, it is 0. And for muon-lepton family, both electron and positron doesn't belong to muon family. So 0 and 0. These two are not a lepton number, so how is it possible to be in a muon-lepton family? So 0 and 0. Similarly, for the tau lepton number, all will be 0, 0, 0. So the electric charge is conserved and lepton number is conserved, electron lepton number, muon lepton number, and tau lepton number all are conserved. So this process is possible. So we have another problem of neutrino interaction. First, we have to check electric charge is conserved or not. For electron neutrino, the electric charge would be 0. For neutron, it is also 0. For proton, electric charge is +1, and for electron, the electric charge is -1. So both these will cancel each other, and we have 0 on the product side as well as on the reactant side. So basically, the electric charge is conserved. Now we have to check lepton number is conserved or not. For electron neutrino, lepton number is +1. Neutron doesn't belong to lepton family, so 0. It is a baryon. Proton is also a baryon, not a lepton, so 0. Electron belongs to lepton number, and it will be +1. So lepton number is also conserved. Similarly, we can check about the electron lepton number, muon lepton number, and tau lepton number. They will also be conserved. Once your lepton number is conserved, all these three will be conserved. And once it is violated, all other will be violated. We have another type of problem. The pion meson decays by the process. Now we have to find to what lepton family does the neutrino belong. This neutrino. Is this neutrino a particle or an antiparticle? And what is its lepton number? So basically, electron charge is obviously conserved there. So starting from the lepton number, for pion, lepton number will be 0. This doesn't belong to the lepton family. For muon, lepton number will be +1. So we have to conserve law of lepton number. For that, there will be -1. These will cancel each other and we will have a 0 on the product and reference side as well. So the lepton number is conserved. So from this, we can deduce that this is an antiparticle because the antiparticle will have a lepton number of -1. So this is antiparticle. The third question is what is its lepton number? So its lepton number is -1. Now, in order to find out to what family does the neutrino belong, we have to solve law of conservation of electron lepton number, muon lepton number, and tau lepton number. Starting from electron lepton number, this will be 0. Muon is not. Muon doesn't belong to electron lepton family, so 0. And as the law is already conserved, on the both side we have 0, so neutrino will also be 0 because having -1 or +1 would affect the law of conservation of electron lepton number. For muon lepton number 0, muon belong from muon lepton family. So here +1. To conserve the law, we must have 0 on right side as we have a 0 on the left side on the reactant side. So in order to get the 0, there must be -1. Both these will cancel each other and we will get 0 on the product side as well. From this, we can conclude that the muon belongs to lepton muon family. So basically it is a anti-muon neutrino. We have another type of problems, that is use a lepton conservation number to determine the identity of X particle in the following process. Here we have to find out the identity of this X particle by using law of conservation of electric charge and lepton number. Starting from law of conservation of electric charge, for tau it is -1, it belongs to the lepton family. For tau neutrino it is 0, and for muon neutrino the electric charge is 0. So from this we can conclude that here should be -1 in order to conserve electric charge on both sides. Now -1 on reactant side and -1 on product side. So after now, we know that particle belong to lepton family. It is a particle, not an antiparticle, not an anti-lepton. So lepton number of tau is positive 1, and lepton number of tau neutrino is also positive 1. And mu neutrino will be positive 1. Now, on the product side, we have positive 1, and on the reactant side, this is plus 1. Wait a second. In order to conserve the lepton number, there should be minus 1. So that minus 1 and plus 1 cancel each other, and we will have a plus 1 and plus 1 on both sides. So lepton number would be conserved. But wait a minute. In order to conserve electric charge, we have assigned minus 1 to this X particle. This clearly means this is a lepton, not an anti-lepton. And by assigning minus 1 in the lepton number, it will indicate that it is an anti-lepton and not a lepton. So here the clash between these two equations, and I think so the given equation is misprinted. There's a certain mistake. So leaving the problem here and moving towards another problem. Electric charge on electron neutrino, the electric charge is 0, and also on electron neutrino, the electric charge is 0, while on electron it is minus 1. So in order to conserve electric charge, the X particle should be assigned the value of minus 1. Now electron number. Electron neutrino is a lepton, so having value of plus 1. Electron neutrino, same, plus 1. Electron will also have a lepton number of plus 1. So on this side we have plus 2. Here must be plus 2. So the X particle would have lepton number of plus 1. So now we have confirmed that X is a lepton number. But which lepton number? Either it is electron, muon, or tau. So we will check electron lepton number plus 1. Also plus 1 because R belong to electron lepton family. Plus 1. So here plus 2 and there must be plus 2. So electron lepton is conserved. So from these values, we conclude that the particle is electron. Because having the negative charge minus 1, we may conclude that the particle may be electron, muon, and tau. But having a positive electron-lepton number, it is clear that the particle is electron. Because electron-lepton number assign the positive one only to electron and electron neutrino. But as far as electron neutrino is concerned, its electric charge is 0. So the particle having minus 1 electric charge and plus 1 electron-lepton number would only be one and only electron. So you understand the lecture. And the next lecture we will discuss about law of conservation of baryon and instantaneous. Subscribe the channel to get updated. Thank you and Allah Hafiz.